Hi everyone, in this video I'm going to present a new and simple method called M.Y method. By this method you can easily design bolt connections without any complicated engineering calculations. First of all, I must introduce you the book of Design of Machine Elements by Graphical Methods for Engineers and Machine Builders. Third editions. Please pay attention. Third editions. By this book you can easily design all machine elements quickly. You can buy the book, all the book from the Amazon site, or you can each chapter separately, only $10 from the Amazon site. Okay, let's get back to example of 5.5 that is related to the piston system, a connecting rod of a diesel engine. Example 5.5. The connecting rod of a piston system is joined to its cap using two wasted bolts, as shown on figure 5.10. Figure 5.10. A force of 20 kN is applied to each bolt. If 20 kN is applied to each bolt, consider the bolt property class of 10.9. Bolt grade is 10.9. Find the size or diameter of the bolt. At first, because the force in machine elements varies from 0 to related force in the pistons, it's recommended in machine elements always use dynamic loads. Therefore, from the dynamic loads, select the applied force. The applied force is 20, and go up to intersect the curve of 10.9, and go to the right to find the bolt size. The bolt size is 12.5 millimeters. We round it up to M14. Therefore, our bolt size is M14. Now we have to find the tightening torque. For find the tightening torque from the vertical axis, select M14 or 14 and go to the right to intersect the curve of 10.9 and go down to find the tightening torque. The upper horizontal axis is for shank bolts, and the lower is for wasted bolts. Since our bolt is wasted bolts, therefore our tightening torque is 145 Newton meters. Therefore, easily we could design the bolt of a connecting rod of a heavy-duty engine diesel. The bolt size is M14 and the tightening torque is 145. Okay, sometimes bolts are under shear loads. For design of them, please refer to next example. Example 5.7. In a press machine, figure 5.14, instead of a pin, an 8.8 bolt is used to hold the plates. We used a bolt to hold the two plates for assembly of this press machine. The force on the bolt is equal to 20 kilonewton. The force on the plate or bolt is 20 kilonewton. Find the bolt size. In these situations, we have two options. If the shear force is one way, this note is from the book. If the shearing force is one way, such as the force of hydraulic presses, and is tolerated by the bolt, or the bolt has been tightened by hand, first multiply the force by 1.3, then select dynamic load or dynamic axis from this picture. Therefore, because the bolt in one option, in first option, because the bolt was tightened by hand, we multiplied the shear load, this shear load, by 1.3, that is equal 26. Therefore, from the horizontal axis dynamic loads, we select 26 kilonewton and we go up to intersect 8.8 curve. We go to the right to find the bolt size. Therefore, our minimum bolt size is 17. We round it up to M18. However, in second option, if shear force is tolerated by friction of plates because of the tightening torque, think we tighten the bolt as much as the tightening friction, the friction force between and the plates be able to tolerate the shear force. Therefore, first multiply the force by 2, then select the dynamic load axis from the horizontal axis of figure 5.13, this figure. Therefore, if friction is important for us, we multiply the shear load, this shear load by 2, that is equal 40 kilonewton. Therefore, from the horizontal axis, we select dynamic loads. As we said, we should use dynamic loads. We select 40 kilonewtons and we go up to intersect the curve of 8.8 because our bolt is 8.8. Therefore, we go to the right to find the bolt size. Our bolt size is 22. Therefore, our bolt size should be larger than 22, but I use M22 standard size. Because the tightening torque is important for us, from the vertical axis select 22, the bolt size, and go to the right to intersect the 8.8 curve, because our grade bolt is 8.8, and count down to find the amount of the tightening torque. Because our bolt is shank bolt, we should use upper axis. Therefore, easily we could design both bolts of a press machine and a connecting rod of a heavy-duty engine diesel easily without any problem. For more accurate and precise calculations, you need to refer to book. In the book there are lots of methods, lots of graphs that you can check your design. You can check your fatigue, your crushing, and your flexibility factor of your design easily without any problem. This method is useful for engineers. However, as uh, we said, uh, the my method is enough for technicians. Thank you for your watching. Thank you for your time. Uh, Please subscribe our channel and like our video. Please wait until next video. Our next video is going to about other machine elements, design of other machine elements such as pin joints, such as universal joints, CV joints, and etc. Thank you for your watching. Goodbye until next video.